Initially, it was the classic, old school micro and immunology department. By that time, the two fields of microbiology and immunology were diversifying, and were really two different departments. Each side tolerated each other, and everybody took turns hiring new faculty. But at the time, Dan Koshland was leading an effort to revitalize biology at Berkeley. There were 40-something biology departments then. There was anatomy, and there was endocrinology, and there was basically he ended up with essentially two departments. There was integrated biology, which was studying ecology and animals and stuff, and then there was molecular and cell biology was the other department. And so I became then the director of the immunology division there were these 6 divisions, and I was the head of the immunology one. And so it was a fantastic time to be at Berkeley. I mean, Berkeley's just a wonderful place, and students are amazing, and the whole intellectual community there is amazing.
How large a division was it?
Well, at first it was Bunny Koshland and I, and then there were a couple other people there. Anyway, we started hiring. It got up to, I guess, 7, 8 people by the time I left. It was small. It was one of the smaller groups there. We constantly had to fight with some of the other divisions because there were a lot of people there who had the idea that if you're a real scientist, you should be studying fundamental mechanisms. How does DNA replicate? How does DNA make RNA? How does RNA make protein? How does a fruit fly's eye develop? The immune system. I mean, people said, "Oh, you can't have a discipline named for a tissue, or whatever." I mean, but my feeling. We used to get in these debates, and I'd say, "Well, maybe, but," I said, the immune system has this innate system. It's really more than one system, but there's the innate part of it, where there are these cells that have hardwired receptors, so they see things that are shared on, all bacteria or kinds of DNA or RNA that are found only in viruses, and they respond and they put up signals. And then you have the other arm, which is the adaptive immune system, where there are these randomly generated receptors, antibodies on B cells and the T cell antigen receptor that are generated completely randomly, and a huge number of possibilities, 10 to the 15th power has been estimated by some people, the different ones that could be made. And they're made randomly, and then they're selected to work and not to attack you. So there's a positive and negative force. And then these things cruise around your body and communicate by touching other cells and each other and secreting little hormone-like things, and it's just wonderfully complex. And I used to argue with my colleagues and say, that's at least as interesting as a fruit fly's eye, because this protects you against disease and doesn't kill you unless something goes wrong, and then it can kill you. And so anyway, but I think we had a really wonderful group eventually of immunologists there at Berkeley.
And did your point of view prevail in the end?
Yeah, I mean, my point of view prevailed with a lot of political help, because Bunny Koshland she was a marvelous woman. She was, as I said, she was a leader in the AAI. She was president years ago, but she was powerful, and her husband was also politically very powerful. And so at first, they sort of helped, and then later on, and with seniority and everything, did well, so nobody could mess with it.